So here on the bench then, I've got a couple of dipole antennas that I've recently purchased just to have a look and test, because I've got a project coming up and I'm going to need quite a few of omnidirectional dipole antennas, the type that you can set up outside and not worry about the weather attacking them. And I found these on eBay from a Chinese seller, really a reasonable price. I think the smaller one, which is 6dBi, cost me around £19, and the slightly larger one, 8dBi, that cost me around £21. So a very reasonable price. If I were to go to a company, say like Cisco, they sell dipole antennas that are very similar to this in dBi and construction, but they can cost well over £100 each. So I thought it'd be interesting then just to take a close look at the construction methods they've used for this, the quality of the construction, and just to open them both up to see what the difference is between a 6dBi dipole and an 8dBi dipole, because there's quite a lot of length difference between the two, the shorter one here and the longer one here, and you've got this extra length there just to gain an extra 2 dBi in gain. So here's a smaller one then, and taking a closer look at the construction of this, it seems really good quality. You've got the end cap here, and this material feels like fiberglass, not plastic, and you've got plenty of sealant around that top cap there, so there's definitely no water going to get into this. And again at the bottom here we've got this metal base here, that the clamp, and the clamp is actually quite nice. The clamp goes over that metal base, so you're not putting stresses on this, which I'm presuming is fiberglass or a really tough plastic anyway. So that's designed to go over that, and this will clamp on to either a wall, or I've got some U-bolts with this. It can go on something like a scaffolding pole, for instance. But again, the sealant, it's really a nice quality construction there. There's definitely no rain or weathering at all going to pregnate that anytime soon. And here we've got a N-type connector for the coax, which you will commonly find on professional installations, not SMAs, and especially for outside as well. It's a lot easier to weatherize an N connector than it is a SMA connector, and it looks like it's screwed in there, threaded in there, so hopefully I'll be able to get a spanner on there and work it loose so we can pull it out. But there's also some kind of sealant in there as well, so they've gone to the trouble of putting sealant where the threads connect there with the N connector, just to make sure that there's no water or anything like that going to get in there. So before I do start tearing these down and taking a look on the inside, then what I'm going to do is give them a test with the alpha card just here in the lab, just to see how many access points they pick up, how well they perform with an alpha card, and we'll have a look at the VSWR as well on the network analyzer. And the VSWR is printed on the information label on this, and apparently it's a 1.5 VSWR, which is typical for a dipole type antenna. So I've got both antennas set up side by side here, as you can see, both using identical alpha cards. So let's give them both a quick scan, and then we'll compare the signal strength between the two. So just let them both load up. So looking at the signal strength between the same access points with the two antennas there, definitely the 8dBi is giving a 2 to 3% increase. There's quite a few access points that are close, so on those close ones both antennas are going to be virtually identical, but I think you can see there that across the range of access points, the 8dB one is performing about 2 to 3% better than the 6dB one. So now that I've had it running here for around 5 minutes and it's all settled down, you can clearly see, if you go through some of those access points and compare them, that the 8dB one is getting 2% to 3% more signal strength than the 6dB one, but of course, you know, the closer that those access points are, there's not a great deal in it. So unfortunately then, I couldn't measure this with any accuracy to test the VSWR with the network analyzer. I just couldn't get a stable signal in here in the lab, but I have got an idea on how I can improve that in the future maybe. I mean, even when I finish my anechoic chamber isn't going to be big enough to accommodate an antenna of this size, but possibly if I can set a rig up outside and just lead it into the lab, that'll probably get around that problem. So as you saw in that test there's not a great deal between them. I have gone back and looked at some of the signal strength, and the longer one, the 8dB one, does have a few percent more than the 6dB one, but with a lot of the access points that are close, you're getting a similar signal strength. It only really shows when you go a little bit further than what the 6dB can do. Then you start seeing a difference in the signal strength, and unfortunately I couldn't hook this up to the network analyzer to test the VSWR. As I said, there was just too much interference and reflections here in the lab. So I'm going to pop them both open then, so we can compare and have a look at what type of antenna this is for a start. It's just sold as a dipole antenna, and then we can also compare as well to see what you have to do to get that extra 2 dB out over this smaller antenna here. So how much of a difference is an 8 dB antenna to a 6 dB antenna? So I'm going to pop this one open first, the smaller one. I think the best way to try and get into this is the top here. There's a 15mm nut on here that I can use a 15mm spanner, but it's really tight because there's some epoxy kind of resin or sealant around the threads there. So what I'm going to do is heat this up slightly and then see if I can loosen it with the spanner. So the heat did the trick then, so I'm just screwing the rest of it off, but you can see there's some kind of epoxy sealant in there. The heat definitely did the trick on that. So that should be good waterproofing as well though. So now that we can see the antenna, now that we've got it opened up, then it's a little bit surprising. I wasn't expecting to find this inside there. It's not your standard dipole design. In fact, it's a collinear design, and you can tell that by these tubes here. There's a few videos on YouTube, and I've made a couple myself very early on, probably around video number 10, 11 or 12, somewhere like that, where you can make a simple collinear antenna just using coax, and it's just you know, small sections of coax around 25 to 30mm long, and it's just the way that you arrange them. You can produce a collinear antenna and it will irradiate, and it's pretty effective design as well. So that's what we've got going on here with these brass tubes. So I think the next step with this then is to get the ruler out and start taking some measurements, and I'm just going to remove this packing around here, which is there to you know, presumably stop this rattling against the body of the antenna, but we've got a little tie off there, so I'll just have to cut that away. So I've measured the tubing with the ruler, and we've got these two here, these two tubes separated by this plastic dielectric in the middle, so they're insulated from each other, and the measurement for these two is coming in at 37mm long, and that's the same with the second two tubes here as well, separated again with this plastic dielectric, so they're insulated from each other, and these as well are 37mm long. But the last two tubes here and here, these are coming in at 36mm long. Now I don't know if that's been done on purpose for the design or not, but you can probably see here on the end it's been cut a little bit rough. They haven't put you know, a great deal of effort into cutting the end off there, but these two are definitely 36mm and not 37mm like the other two. So I'm not sure what's going on with the design there. So what I'm going to do, I'm going to test this with continuity, just so I can find out which one of these tubes is ground and which one is connected to the signal wire, the center pin wire on the end connector, and then I can draw it out and we can go through the design just so I can show you that it is a collinear design. So now that I've had time to take a look at this design and try and get an idea of how it works, I've put together this diagram here so you can see more clearly. And basically what we've got is this tube in here, which is connected to the ground plane, is 110 millimeters long. Now this first section of tubing here, the wider tubing, that is connected directly to the ground plane on the N-type connector here, so I've put a G there. Now the next set of these wider tubes are not connected to the ground plane or the driven element, so I can only assume that they're acting a little bit like a parasitic element on a Yagi, for instance. And then the last one here at the end, that is connected directly to the driven element. That's the center pin on the end connector. Now I've never come across this type of design before. Now whether this is you know, typical in the radio ham circles, for instance, at different frequencies, I don't know. People have asked me previously if I'm a ham radio enthusiast, and I'm not. I don't have a license, but it's a very intriguing design. And as I say, if you have come across this before and you know what the design is actually called, then please let us know. I'm still erring on the side that it's a collinear type design and belongs to the collinear family rather than dipole family. But I was a little bit concerned that it feels as if it's kind of broken around this area here, so I thought that maybe, you know, these tubes here are, you know, designed to be connected to the ground plane, and it's just snapped in the middle there, so it's lost its connection. So I've taken the larger one out and taken a look at that, and that's not quite so, you know, it hasn't got as much play there, so it's a little bit more rigid. And again, the longer one, this one's connected to the ground plane, but this one, and this one aren't connected in any way to the ground plane or the main driven element, and this at the end here is connected to the driven element, just like the smaller one. But yeah, I haven't come across a design like this before. So it does seem a intriguing design, and I am going to order some parts, some brass tubing, to build some prototypes of this so I can have a little play around with this design. But basically it's set out. You have the tubing here, as I said, that's 110 millimeters, and then you've got your two longer lengths of tubing here. This one's the ground plane, this one isn't connected to anything. That's space in there between the next piece of tubing is 13 millimeters, and so on here again 13 millimeters. And definitely the last two you know, lengths of tubing here, the driven element one as well, they are a millimeter shorter than the others, and I don't know if that's just an error in cutting, but they are definitely 1 millimeter shorter. So now that I've got the longer one opened up, we can compare each design side by side. And the first thing that I notice is the thinner tubing here, the first part of the tubing. On the shorter one it's slightly longer, but on this longer antenna here it's slightly shorter, so I think that possibly the thinner tubing here doesn't play so much of a crucial role in determining the center of the frequency of the antenna, but it's certainly shorter on the longer one here. And if I put the antennas side by side, you can clearly see that the longer 8dB antenna here at the top, the tubing is only 36 millimeters as opposed to the 37 millimeters on the 6dB antenna, so these are a lot shorter. You can physically see the different length there. So, you know, I'm not really sure whether they've had to make it shorter in order to accommodate the extra tubing to make this an 8dB antenna, or it's just an error in cutting, and you know, it's a sloppy poor way of constructing it. You know, they haven't really gone into constructing this with any great accuracy at all. but these are definitely 36 millimeters on the 8dB one, so definitely shorter. And the end driven element tubing here is also 36 centimeters, so all these ones are 36 centimeters, quite uniform all the way through the design of the antenna. But on the 6dB one, these are definitely 36, and the rest of the tubing is 37 millimeters. So as I say, I don't know if that's a design consideration in the different dBs of the antenna, or it's just sloppy construction techniques. I don't know. So I decided the best way to start deconstructing this is from the top down, and I've got the main driven element tubing desoldered here. You can see it's just a slit cut in the tubing and folds over this piece of copper wire here that's connected to the center pin on the end connector. But we've got these spacings here, these plastic spacings, and they've got threads on, and these aren't threaded into the tubing, so I think these have been repurposed from something else. And indeed, in the longer one, we've got some black spacings here, so definitely different parts have been used in the construction of these antennas. So as I say, probably repurposed, because there's no threads making contact with this tubing here, and certainly no threading inside this tubing to screw it down onto that. So it's not looking good. Also, this is a solid piece of copper wire. I think it is copper wire and not any kind of coax in any way, so it's probably not going to be 50 ohms either. So I may have jumped the gun a little bit, because these threads are threaded into these lengths of tubing here, and it seems to be quite modular. I've just unscrewed this one from this middle set of tubes here, and that's how they're getting the isolation. This is the isolation, so they're not connected to each other, and these two tubes here are connected to each other through this brass tubing. So if you get continuity, you do get continuity from these two tubes here. So each sets of two tubes are independent from each other, and this ground plane one is the only one that's connected to the ground plane. This one is isolated, so it's quite a modular design. And now that we can open it up and take a look at the center part of the antenna, this is looks like really cheap coax. It's got this dielectric around it here that kind of resembles TV coax wire. So I will say that it's probably not around 50 ohms. It's probably just copper wire they've got lying around the factory. But yeah, I haven't seen a design like this before. So each one is modular, so effectively, if you purchased a few of these parts, you could make antennas up as long or as short as you wanted, with the dB range. So sticking an extra pair like this in line with the antenna, over the shorter one, does give you that extra 6 dB of gain that they claim. So yeah, if you do know what kind of design this antenna is, then please let us know in the comments, because I'm unsure, and I've had another quick look, and I can't find any reference to this design at all. So now that the antenna's deconstructed, we can really see how this is put together. And if we start at the bottom here, this brass tubing here is ground plane connected to this first tubing, and then we've got these two sets of tubes here, and these are independent of each other. They're not connected in any way to the rest of the antenna, but they are connected in pairs, and these are just screwed on top of these plastic threaded bits here that also act as an isolation. And then we've got the final tube here, which is connected to the copper wire here at the top, which is our driven element. So a really modular design. I mean, when you've got the bottom half of this soldered up, it probably doesn't take any time at all to construct the rest of the antenna. But again, the quality isn't all that. There's small cracks in the tubing. Some of the tubing is just cut off quite roughly. It's got saw marks on there. They haven't really taken any effort to file that down and make it a little bit neater. but also the measurements of this these tubes here. These ones are 37mm, but on the longer range one, the 8dB one, these are definitely cut off at 36mm. So the inconsistencies over the measurement there, unless you know you've got to do that because you know adding an extra pair of these tubings here will affect the measurements of the antenna, I don't know, which is a good reason to get some parts in and have a play around with this design. So it just goes to show then that you don't really know what you're purchasing off something like eBay. The outside of this is really quality. As I said, the casing here is certainly fiberglass. You've got this heavy metal part here that the clamp can clamp onto, and you got the threads to screw the end connector in. So really solid and watertight design. But then when you take a look on the inside, not so much effort put into the quality of construction of that. You know, it's a little bit shoddy. The cup marks are still on there, no filing or you know any attention to detail at all. So it's only when you take a look inside something like this then you know you can see why it's only £20 off eBay. So as far as the project that I've got coming up, I'm probably not going to use any of these, so I just ordered a sample just to see you know what they were like. But I will definitely keep the outer casings and the end connector, because I do think I can improve on this and make something a little bit more quality, and use the outer casing here for that antenna. For that reason alone, you know, this is probably worth the £20 price tag for this fiberglass casing with the metal and also the mounting bracket as well and the end connector. So just a quick video then taking a look inside of one of these, and as I said, I'm not very impressed, but I will definitely do some follow-up videos experimenting with this design. So I hope you enjoyed the video, and if you do know what this antenna is called, then please let us know in the comments. And if you did enjoy the video, please give it a thumbs up, comments or questions below, and you know, hopefully you'll join me on the next one.